Hello everyone, my name is Sameer Singh and I'm a technical marketing engineer at Infoblox. In this video, we will take a look at how we can leverage Infoblox threat defense to protect our infrastructure in AWS environment from threats by inspecting the DNS queries made by the hosts to the internet. Amazon Route 53 is AWS's scalable and reliable DNS web service. It handles domain registration, DNS routing, and health checking. The reliability and scalability it provides ensures access to the resources at all times, and AWS makes it very easy to set it up and add the required records. Route 53 Resolver provides recursive DNS query resolution for AWS resources, public records, and private hosted zones within Amazon VPCs. Now, the other very important factor to consider when making DNS queries is security. As every connection starts with a DNS query, protecting DNS can stop both known and likely threats earlier without compromising network performance. This is where Infoblox Threat Defense can work in conjunction with Route 53 to prevent network threats in your AWS environment. Infoblox Threat Defense is a cybersecurity solution that leverages DNS as the first line of defense. It combines Infoblox DNS Firewall, Threat Intelligence Data Exchange or TIDE, and Dossier to detect and block cyber threats. The regular and up-to-date updates related to new threats identified and insights created based on extensive research and AI ML algorithms help improve SOC efficiency by identifying and mitigating threats effectively and at the earliest. Considering these advantages, it could be a good approach to forward DNS queries from your AWS environment to Infoblox Threat Defense for inspection. And this video will walk you through with these steps to enable that. We will be forwarding DNS queries to publicly hosted domains to Infoblox Threat Defense and use AWS Route 53 hosted zones to resolve queries to domains and subdomains for internal AWS resources. For this demo, we have a test machine running in a VPC with an interface in a private subnet. By default, the test machine will send the DNS queries to Route 53, and we need to forward the DNS queries for external domains to Infoblox Threat Defense. The first thing we need to do is create a Route 53 resolver outbound endpoint. An outbound endpoint allows DNS queries from your VPC to be forwarded to DNS resolver in your on-premise network or hosted in the cloud, enabling seamless hybrid DNS resolution. Navigate to Route 53 resolver outbound endpoint and click on Create Outbound Endpoint. Provide a name for it. From the VPC drop-down, select the VPC in which the endpoints will be deployed. Further down, you can select the availability zones and the subnets that are part of the selected VPC, in which the endpoints will be deployed, ensuring all hosts are covered. Apply the appropriate security groups. Make sure the required outbound rules are added in the security groups selected. The endpoints can have an IPv4 address, an IPv6 address, or both. Endpoint protocols determine how data is transmitted from the outbound endpoint. We can select if we want an added level of security where data cannot be decrypted by unauthorized users. Adding two different IP addresses help to improve reliability, and it is recommended to have them in different availability zones in case one of them becomes unavailable. Additional IP addresses can also be added if required. You can add relevant tags and create the endpoint. Next, we will create forwarding rules where we will define the target to which the queries will need to be forwarded and for which domains. Move to the Rules section under Resolver and click on Create Rule. Provide a name and leave the rule type as forward. In the domain name, you provide the domain names for which you want to forward the queries. In this case, since we want to forward queries for all external domains, we will mention a dot. Select the VPC to which this rule will apply and the outbound endpoint created earlier. In the target IP address, provide the Infoblox Anycast IP address to which the endpoint will forward the query to. The query will be forwarded to the first available healthy address from this list. Add any relevant tags and click on Submit. Next, create a forwarding rule for domains that need to be resolved by Route 53. In this rule setting, select the rule type as System. Enter the domain for which Route 53 will resolve the queries. These will likely be the private hosted zones in AWS. Select the VPC to which the rule will apply, and we will have two rules configured for this requirement. Now, let's look at the networking requirement in AWS to forward the queries to Infoblox Threat Defense. We will use a NAT gateway in this demo. The internal hosts will forward the DNS queries to the outbound endpoint, which will then forward it to the NAT gateway. The NAT gateway will perform NAT on the packet and send it to the target with the source as the NAT gateway public IP address. Now navigate to Virtual Private Cloud, NAT Gateways, and click on Create NAT Gateway. Provide a name for the gateway and select the subnet in which it will be created. Leave the connectivity type as public and select the elastic IP address that will act as the public IP address of the NAT gateway. Add any relevant tags and create the NAT gateway. In the subnet section, select the subnet in which the resolver outbound endpoints are added and select its corresponding route table. We will add a default route in this table, which will point to the NAT gateway. This will ensure all the DNS queries expected to be forwarded to the Infoblox Threat Defense reach the NAT gateway, from where they will have internet access to reach the Anycast IP address that I mentioned earlier. Now that we have our setup ready on AWS end, let's make the necessary configuration on the Infoblox portal. After logging into the portal, navigate to Configure, Security, External Networks, and click on Create. Here, we will define the network from which Infoblox Threat Defense will be receiving the queries and require protection from malicious attacks. Provide a name to the network, and in the subnets section, enter the public IP address of the NAT gateway which you have created in your AWS environment for this purpose. Next, define the security policy that will be applied to queries coming from this source. To do that, navigate to Configure, Security, Policies. You can create a new policy or clone the existing default global policy. This will ensure that the default recommended security rules are already part of your policy. Provide a name, and in the Network Scope section, choose the source as external network and select the external network object that you created. In the Policy Rules section, you can add other relevant rules you want as part of your policy. Post that, review the changes made, and create the policy. This completes our setup. And now let's initiate some traffic from the test machine to verify that it's working as expected. Log into the test machine and run a dig command for google.com. Next, run the dig command for t1.test53.com, which is a private hosted zone in AWS. Notice the response where it returns the IP address added as a value for the record in Route 53. Let's also try accessing a site that is blocked by the threat defense. We can see the access to the site is blocked and threat defense redirects it to a standard Infoblox redirect block page. Now, let's go to the Infoblox portal to see the DNS activity logs generated there. Navigate to Monitor, Reports, Security and DNS Activity and notice the logs. The logs for DNS query initiated to external domains can be seen here with the source as the DNS NAT gateway IP. We can also view the logs for the blocked site in the security events, providing details about the site that was blocked, the policy that blocked it, and its source, which can be used for further investigation. If any compromised host in your AWS network attempts to access any C2 server or access any malware site, it will get blocked by the threat intelligence provided by Infoblox and protect your network. This brings us to the end of the video. I hope this was useful to you and thank you for watching.